Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy resilient and energy independent. Today we're going to be going through a battery system that is a do-it-yourself battery system. So it's giving people the opportunity to make their own battery for different applications. So you can make it for an RV, you can make it for a home energy storage system, or you could make it for a cabin energy storage system. You can make also high power battery packs with this system, and that's really the key benefit that this system brings to the public that are interested in making batteries. So I've got a couple visual aids here. This is the system that they have for sale on eBay. It consists of four 3.2 volt nominal 105 amp hour cells, and they're already configured to be assembled in a series configuration, so it'll make a 12 volt battery if you just add the 3 bus bars on the system. So that would give you, it's got the polarity on there, so this is negative and this is positive. So when you make those connections, that gives you a 12 volt battery. The key benefit of this system is that the bus bars are already laser welded onto the system, and then they are adjustable. So it comes with bolts and bus bars to attach the main bus bars from the cells to the battery adjacent to it that allows you to make it in series. The key benefit of using a system like this is that it makes it very compact and very easy to hold down. So there's eyelets in the bottom where you can bolt the system to your enclosure if you're putting it in an enclosure, or directly into an RV floor or sidewall to mount the battery. With these systems, they do not have a BMS built in. It doesn't come with a BMS. So to add flexibility, you're able to use whatever size BMS that you would like, whatever current level that you need, you can design the system to do it. These specific cells are rated at a 1C discharge, so that's 105 amp, and then a pulse of 3C, which is 315 amps. So when you're building your battery pack, you're going to build it and make it at the voltage level for whatever system you're going to be powering. So for an RV, that would be 12 volt. For kind of more of a home energy storage system or cabin energy storage system, that would be usually a 48 volt system. But then when you get into maybe electric shifter carts or electric cars, then you can get up into 100 volt range, maybe for a shifter go-kart, and then up to 400 volts for a car battery. So this is 100 amp hours, so as you stack voltage, it's increasing the power that you're able to get out of the battery, and it's also increasing the energy storage that you have in the system. So when you're making it, like in a Tesla car, they have, I believe, 24 volt modules, and so they will have a module like this that's 300 amp hours but 24 volts. So you add more batteries to the system using this extra piece. So if you unbolt this and take the end component off, you put in an inner component, and then you can stack 2 of these systems together, and that would give you a 24 volt system. I do have 2 of them here, but this would be your approximate size for a 24 volt battery system, and then 4 of these would make it 48. Another option you would have would be to make your own bus bars for this system. So if you reorient the cells in this package, you can put all of the polarity, so all the positive on one side, all the negative on the other, and that gives you a multiplicative effect in amp hours, but not in voltage. And so you can make this become a 420 amp hour 3.2 volt battery. And so if you put 4 of these in series, that would give you a 12 volt 400 amp hour battery. The bus bar system that comes with this is designed to stack voltage, so it's to go to 12 volt in this case, so you'd have to engineer your own components to make your bus bars in that case. And then to make the connection to the next battery, you would have to either build it in on the bus bars, or you'd have to make some other accommodation. So I would recommend you just stick with the kind of voltage stacking capability of this system instead of doing multiple batteries in parallel within it, giving it more amp hours. So just stick with the 12 volts, 24 volts if you do 2, or 48 volts if you do 4. And then if you do want to go beyond that, you could do 8 of the packs to get to around 100 volts. But you can really engineer it and design it to fit whatever your application is. So if you're wanting to build a electric side-by-side, or maybe you're on a formula hybrid team for a college or something, you could use these batteries, stack them to the voltage that you want to operate at, and then add a BMS. So now going into the BMS, usually you would want a kind of a nicer BMS system. There are kind of cheaper BMS systems where it will just protect against overvoltage, but not undervoltage. So in that case, you just have a circuit that goes across each cell, and it's just watching that voltage. And if it ever goes above the limit, which for lithium iron phosphate, 3.65 is the normal limit on the top side. So if it goes past that, it will just add a little resistive circuit. It'll just connect it and drain that battery a little bit to get it back down to the top voltage. And so that, in effect, balances the cells. So as you're charging this whole pack, one cell will sometimes get a little high on voltage, and that's because that cell is actually getting to full. And so then as soon as you take charge off, that little circuit will take that cell back down to the stable, safe voltage. Just as kind of a helpful hint, if you do charge these batteries 1/10 of a volt above the limit, which is 3.65, so 3.75 or above, if you hold it at that voltage, the battery composition will break down and the battery will swell within 24 hours. It's a very fast process if you overcharge these cells. So that's something you need to watch, especially just when you're setting up the system at the start. You want to make sure all of your batteries are balanced. These are shipped at a standard state of charge, and they're all the same. So as long as you don't charge or discharge them, you can just hook them up and get them into a series set and be ready to go rather quickly. Some of the other really nice features, this is glass reinforced plastic, so it is very impact resistant, and it also has built-in straps at the 12 volt size. So when you assemble the system, bolt it together, and that holds it firmly. So as the cells age and they grow a little bit, usually the cells will increase in size slightly as you're cycling them. Having them confined in a system like this will add to the cycle life. So it keeps it compressed and keeps the internal resistance lower, which as the internal resistance increases, you're gonna have other issues, like when you're drawing a lot of current. If the internal resistance is double, then your voltage sag on the whole system will be doubled. So voltage difference from just sitting there open circuit to under load at a specific value would be double, and then quadruple for 4 times the internal resistance. And in general, like all the data sheets, the data sheet for this specific cell in the past has always been that if the internal resistance doubles, then that cell is ready to be recycled and you should replace it. It's not a hard fast rule. A lot of the suppliers currently in China are starting to push away from that and allowing a higher internal resistance. As long as your BMS can account for that during high discharges, that's fine, but you may get some low voltage warnings that are more frequent just because of the internal resistance of the cells. But this is an amazing system. It all comes ready to go, so you can do the 12 volt pack. It comes with an extra piece to interconnect it like a Lego system, and that allows you to keep stacking to make the voltage that you need. So it's a super slick system. You can just keep building it, get up to the 48 volt or whatever size you want to do, and then from there you can assemble it into bigger packs if you're doing like a high voltage battery for automotive application or go-kart application or something that's higher end, a lot higher current. So thank you guys for watching. This is available now on eBay. I'll throw a link in the description so you can get to it, and then on the eBay page I will add this video also to describe how the system works. I will be working on a little unboxing and assembly video to help you guys assemble it more efficiently in the future, and that will be added to the eBay post as well. So if you guys have any questions on this or any comments, any concerns, please like and subscribe and add your comments below the videos. We're always open to learning what you guys are interested in and what problems you're running into on the systems that you're building. So Thank you guys. We'll talk to you next time. Have a great day. See ya.